today's lab that we're going to do, we're going to do the roller coaster lab part B3. And with B3, it's going to be very similar to B1, parts 1 and 2, but this time we're going to throw in a new player. We've been doing with the steel marble, now we're going to do it with the plastic blue marble. And the biggest factor between these two is their mass. The steel marble is going to weigh in at 28 grams. The blue plastic marble is only weighing in at 4.1 grams. And so that's going to be the biggest independent variable, or the biggest factor that we're playing around with today. So the focus is, how does the mass influence the speed? In the last two labs that we've been doing, we've been focusing on potential energy, kinetic energy, how those factor into speed, position, time, those kinds of things. You've also done a gizmo in which you guys were putting different objects with different masses on shelves to see how that affected potential energy. And then in activities B1 parts 3 and 4, you should have found out that height does factor into the transformation from potential to kinetic energy. And so that's what we're going to play around with this a little bit today to see how mass comes into play with that as well. So like I said already, the independent variable is going to be the mass of the marble. Here are the masses of the marble: steel at 28 grams, the plastic marble at 4.1 grams. The dependent variable, just like before, is going to be our time spent in the photo gate, and the time spent in the photo gate will be used to calculate speed. Just like the steel marble, the diameter of the plastic marble is 1.9 centimeters. They're the same exact size, they're just a different material. So that's one of our controls. The starting point up at the top of the roller coaster is a control. And then the roller coaster is still set at stand hole number 5, sorry. All right, so as I go through this, and before we start this, you guys are supposed to distinguish if there is some sort of, or if you think there's going to be some sort of difference between these two marbles as they roll down the track. If there's going to be a difference at all, or if there is going to be a difference, you need to decide what that's going to be, and you're going to write that down on your student sheet. As we go through the lab, we've already collected the data for the steel marble. We did that in B1, parts 1 and 2. There were the 7 positions throughout the roller coaster that you guys already saw. We've collected the data, we measured it all out, so we don't need to do the steel marble, we're just going to transfer that data. We are going to do the blue plastic marble though, so we're going to add that data to this sheet. So for the first trial, the photo gate is set at 7.5 centimeters down the track, and to measure height, the height is at 35 centimeters. So trial. All right, now trial 2 is going to be 22.5 centimeters down the track, position 2. And position 2 is 25 centimeters off the tape. Position 3, 43 centimeters down the track. And at 43 centimeters down the track, it is 15.5 centimeters high. Position 4, 62.5 centimeters down the track. At 62.5 centimeters down the track, 23.5 centimeters off the tape. Position 5 is 82.5 centimeters down the track. And at 82.5 centimeters down the track, it is 32.5 centimeters high. Good. Position 6 is 105 centimeters down the track. And at 105 centimeters down the track, 22.5 centimeters high. And finally, position 7 is going to be at 127.5 centimeters down the track. And that is going to be 12.5 centimeters high. All right. Perfect run. Didn't have one marble get flung off. So what you guys are going to do is you're going to calculate the speed, and you're going to see if there is a relationship between mass and speed.